Hello friends, today we are going to statistic binomial distribution. Don't forget, we just proved the mean, the variance of a binomial distribution. We want to look at example on it. We have a question before us here. If 20% of bulbs produced by a factory are defective, determine the probability that out of 4 bulbs chosen at random, 1 will be defective, 0 will be defective, at most 2 will be defective. And the second part of it, we are to obtain the skewness and kurtosis of the data in A above. So let's solve the question direct. From this question, this percentage is our P. So our P, which is the probability of defective, is 20%, which is 20%, and this is 20 divided by 100, and the answer is 0.2. So if our P is this, then our Q, that's the probability of not defective, will be equal to 1 minus P. And the answer will be 1 minus 0.2, which is equal to 0.8. So this is probability of defective, and this is probability of not defective. The question asks us to find the probability that 1 will be defective. So the total bulbs chosen is 4. That is our N. Our N is equal to 4. So if you recall, the binomial distribution, we're given a probability of x equal to n combination x, then p raised to the power of x, q raised to the power of n minus x. We can easily solve for number 1. That is, 1 will be defective. It means x is equal to 1. So x is equal to 1. We substitute to this. Anyway, we find x. So our n is 4. So we have 4 combination 1, then times p, 0.2, 0.2 raised to the power of 1 times q, 0.8 raised to the power of n, 4 minus 1. So this is the same as 4 combination 1, then times 0.2 times, this is 0.8 all raised to the power 3. So 4 minus 1. So I will know that n combination r is given as n factorial all over n minus r factorial r factorial. So we are going to use it here. This will be 4 factorial over 4 minus 1. So which is 4 minus 1 factorial, then 1 factorial. So 1 factorial is 1 times 0.2 times 0.8 times 0.8 times 0.8. So in 3 places. So this is the same as 4 times 3 factorial all over 4 minus 1, 3. So 3 factorial. So this will easily cancel this. Times 0.2 times 0.8 times 0.8 times 0.8. So it will be 4 times 0.2 times 0. And we can easily use calculator to simplify. And when we simplify with calculator, If we simplify with calculator, so we discover our answer will be 0.4096. So this is the probability that only one will be defective. So the second question is find the probability that 0 will be defective. So let's find the probability that 0 will be defective. The probability that 0 will be defective. Here our x is 0. We have probability that x is equal to 0 will be equal to 4 combination 0 times 0.2 all raised to the power of 0, then times 0.8, which is our cube, 4 minus 0. So this one will be 4 factorial over 4 minus 0, 4 factorial, 0 factorial. Then times nth raised to the power of 0 is 1 times 0.8 all raised to the power of 4. So this will easily cancel this. And we can find the 0.8 raised to the power of 4. That is 0.8 in 4 places will easily give us 0.8 raised to the power of 4 will give us 0.4096. 0.4096. So this is the probability that 0 will be defective out of 4 balls chosen. So at most, that's the next question, at most 2 will be defective. At most means from highest to the lowest. So the highest is 4. So, but they say at most 2. So from 2 downward, which is 2, 1, and 0. So we are calculating the probability of 0, the probability of 1, and the probability of 2. Then we add the probabilities. That will be the probability of at most 2 will be defective. So probability of x here at most can be written as less than or equal to 2. Probability of x less than or equal to 2. That's at most from 2 downward, which is the same as probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2. So we've calculated the probability of x equal to 0. That's the first thing we did here from question 2. We've also calculated the probability of x equal to 1, which is in question 1. So now let's calculate the probability of x equal to 2. Then we can easily add this 2 to this. So let's find the probability of x equal to 2. So we should be 4 combination 2 times 0.2 raised to the power of 2 times 0.8 raised to the power of 4 minus 2. So this will be 4 factorial over 4 minus 2. 2 factorial, 2 factorial times 0.2 all square, then times 0.8 all raised to the power of 2. So we can express this. This one is 4 times 3 times 2 factorial all over 2 factorial 2 times 1. So I'm leaving this in 2 factorial because this will cancel this. So 2 here, 1, 2 here, 2. So left with 2 times 3, then times 0.2 raised to power 2 times 0.8 raised to power 2. So the answer for probability of x equal to 2 now will be 2. So we are left with 2 times 3 here 6. 6 times 0.2 square, then times 0.8 square. The answer will be 0.1536. So we are adding everything here together now. We are adding this to probability of 0 to probability of 1 in order to get probability of x less than or equal to 2. Let's do that. So we are going to have a so we discover that the probability of x equal to 2 or equal to 0 is equal to 0.4096. So probability of x equal to 1. So we got 0.4096, and the probability of x equal to 2 is equal to 0.1536. So we are going to add everything together now. Therefore, probability of x less than or equal to 2 will be equal to this plus this plus this. So which is so it will be 0.4096 plus 0.4096 plus 0.1536. And when we add everything, we are going to have a 0.9728. So this is the probability that at most 2 will be defective. So we are done with question A. Now let's move to B part of the question. So the B part of the question says you should obtain the skewness and the kurtosis in this data. So how do we obtain the skewness? This is the formula for calculating the skewness. Skewness or coefficients of skewness is given as which is alpha 3 is given as q minus p all over square root of npq. So don't forget our q is given as 0.8 and our p is given as 0.2. Our n is equal to 4 from the question. So let's substitute now. Alpha 3 equal to q. Our q is 0.8 minus 0.2 all over square root of n, which is 4, times 0.2 times 0.8. So when you subtract this, it will be 0.6 all over. So let's multiply this. We have a 4 times 0.2 times 0.8, which which is 0.64. 0.64, and when you find it, this will be 0.6 all over 0.8. So if you divide 0.6 by 0.8, our answer will be 3/4, or 0.75. So this is moment coefficient of skewness. We can also obtain the second one, which is kurtosis. So let's find the kurtosis. So alpha kurtosis is given as 3 plus 1 minus 6 PQ all over MPQ. So this is the formula for calculating moment coefficient of kurtosis. So let's substitute this. So this one will be 3 1 minus 6 times P. Our P is 0.2 times Q 0.8 all over 4 times P 0.2 0.8. So this is 3 plus 1 minus, so let's simplify this. We have 6 times 0.2 times 0.8. So this one will be 0.96 all over 0.64. So this will be 3 plus, when you subtract this, we have 0.04 all over 0.64. So it's equal to 3 plus, so this divided by this, we get 0.0625. So we add it to this. So this will give us 3.0625. Therefore, this is approximate to 3.06. So this is moment coefficients of kurtosis. That is all about the question. Thanks so much. Please try to subscribe to my YouTube channel in order to get new notification when a new video is uploaded. So I remain Akambi as the formula. That is my YouTube channel name. Always search for it and you see more questions to tackle with. Thank you.